This is question 9 of the CSEC math exam January 2013, and this question gives us a function for the velocity y of a particle after x seconds, and this is it. Y is equal to 3 divided by x, where x is not equal to 0. They give us this table, and the first part of the question wants us to complete the table. So basically we want to complete these 3 cells. So for this y value here, the y value for here is obtained when the x value is 0.5. And so at x equals 0.5, y would be equal to 3 divided by 0.5. Remember now, y is equal to 3 divided by x. And so when the x value is 0.5, the y value is 3 divided by 0.5. And the result for that calculation is 6. And so we can place the 6 inside this cell. For here, the x value is 3, and so at x equals 3, we calculate the y value by dividing 3 by 3. That works out to be 1. And so when x is 3, y is 1. And so the value for this cell is 1. Here we have x equals 5, and so we are solving for y when x equals 5, and in this case y would be equal to 3 divided by 5 because x is 5, and 3 divided by 5 is 0.6, and so the value for this cell is 0.6. And that's it. We have completed the table. Let's move down now to part 2. Now part 2 wants us to draw the graph of this function for these values of x, for these values, and we're required to use a scale on the x-axis of 2 centimeters to 1 unit, and on the y-axis 1 centimeter to 1 unit. And you can see that I've already scaled this graph. On the x-axis, 2 centimeters to 1 unit, so it's 2 centimeters is 1 unit, and on the y-axis 1 centimeter is 1 unit, and therefore 2 centimeters is 2 units on the y-axis, and so 1, 2 on the y-axis, and those are the scales. And all we need to do now to plot these values from the table is plot these points. So for an x value of 0.25, the y value is 12, and so we are plotting the point 0.25, 12, and for an x value of 0.5, the y value is 6, so we're plotting the point 0.5, 6, and so on down to the point where x is 6 and y is 0.5. And so we are plotting these points. And so these are the points. This point here is the first point. X is 0.25, 0.25, y is 12. That's this point here, 0.25, 12. This point, 0.56, x is 0.5 here, and the y value is 6. The third point, x is 1, y is 3. This is it. 1, 3, x is 1, y is 3, that's this point here. The fourth point, x is 2, y is 1.5, so the point is 2, 1.5, x is 2, 1.5 here. This point is 3, 1, and so it is x value of 3, y value of 1 right here. And here for this point, x is 4, y is 0.75, and so it is 4, 0.75, that's it. This point, x is 5, y is 0.6, so x is 5, y is 0.6 here, 0.6, and the last point here, x is 6, y is 0.5, and so x is 6, y is 0.5. So these are the points from this table, and all we need to do now is draw the smooth curve through those points, and this is it. And so that's the graph, smooth curve through the points, and that is the answer for this part 2 of question 9a. Let's move down now to part B of question 9. Now part B gives us this quadratic function f of x equals 3x squared minus 5x plus 1. This quadratic function is in the standard form, and we are asked to write it in this form. This is called the vertex form for the quadratic function. And to convert this standard form to this vertex form, we can use a process of completing the square. Now there are several methods of computing the square, but the one we are going to use in this example is one that involves using the coefficients of the terms in the standard form to find the terms in the vertex form. So we're going to be converting this f of x from this standard form into this vertex form. In this vertex form, what we want to do is determine the value for a here, xt here, and yt here. Xt and yt are the x and y values at the turning point of the graph of the quadratic function. So xt is the x value at the turning point and yt is the y value at the turning point. And so the t here simply means turning point. And the xt can be calculated using the coefficients of the terms in the standard form, and also yt can be calculated using the coefficients of the terms in this standard form. And the coefficients of the terms in this standard form are given these notations. A represents the coefficient of the x squared term, and that is 3, and so a is 3. B represents the coefficient of the term in x. The coefficient of x in this case is -5. We have to carry the sign as well, and so the coefficient of x is given the letter b, and that is -5. And then c is the constant term in the quadratic expression, and therefore c is equal to 1. So for this quadratic function, a, the coefficient of x squared is 3, b, the coefficient of x is -5, and c, the constant term, is 1. And then, as I have said, a, b, and c can be used to calculate xt and yt here. And the a here is the same a here, which is the coefficient of x squared. And the definition for xt, the x value at the turning point, is -b divided by 2a. The b is the coefficient of the x, and the a is the coefficient of x squared. And the yt is calculated using this formula. Yt equals 4ac minus b squared divided by 4a. A, b, and c again are the coefficients of the terms in the standard form as listed here. And so we can calculate xt first, and this is it. Xt is negative, that's this negative sign here. And the b now, the b itself is -5, so this becomes -5 divided by 2 times a, and a is 3. And when we do this calculation, -5 is +5, and 2 multiplied by 3 is 6. And so this reduces to 5 divided by 6. And then if we put the values for a, b, and c from here in this calculation for yt, it works out to be 4, that's this 4, ac, a is 3, and c is 1. So 4ac here is 4 times 3 times 1 minus, this minus is not squaring, but we are squaring b. And so it's minus b, which is -5 squared. So remember, this minus is not squaring, but we are squaring the negative inside the bracket here. And we are dividing by 4a. 4 times a is 3. And when we do this calculation here, this will be 4 multiplied by 3 multiplied by 1, that's 12. And here we are squaring -5, it becomes 25. So what we have on the numerator really is 12 minus 25. So 12 minus 25 is -13 on the numerator, and on the denominator is 4 multiplied by 3, which is 12. And so this works out to be -13 divided by 12. So now that we have our xt value and our yt value, and we know that a is 3, we can go ahead and place these values in this vertex form such that f of x becomes a, which is 3, into x, that's this x, minus, that's this minus, xt. Xt is 5 divided by 6 from here, so that's the xt value. We should remember to place this square outside the bracket, and then we want plus yt. Plus yt is -13 over 12, and therefore plus yt is -13 over 12 here. And this is f of x in the vertex form with the square completed. So f of x is a, which is 3, into x minus xt, which is 5 divided by 6, square outside the bracket, minus 13 over 12. Minus 13 over 12 is our plus yt value. And so here we have completed the square. Now the question wanted us to give the value for A, the value for H, and the value for K. Question required those values, and so we have to compare our final form, this vertex form, with this form that was given. And when we compare this form with this, so we can write the value for A, H, and K, we see that A is 3, H is 5 over 6 because we have minus H here and we have minus 5 divided by 6 here. And so H is 5 over 6, and then plus K is equal to minus 13 over 12. Or plus K here will be minus 13 over 12, and therefore K is minus 13 over 12. So these are the values. A is 3, H is 5 divided by 6, and K is negative 13 divided by 12. And so that completes part 1 of this question 9b. Let's move down to part 2. Now what we have so far is the standard form f of x equals 3x squared minus 5x plus 1. And when we write it in the vertex form using this method, we end up with this expression with the square completed. And what we have is that xt, the x value at the turning point on the quadratic graph for this function, is 5 divided by 6, and yt, that is the y value at the turning point on this quadratic graph, is negative 13 divided by 12. And we are required now to state the minimum value of f of x and the value of x for which f of x is minimum. Now this quadratic graph will have a minimum value because the coefficient of the x squared is positive, and so this function can only have a minimum value because the expression here can only be positive, and that minimum value is going to be the yt value, this yt value here, and the function will be equal to this yt value, which is the minimum value of this function when x is equal to the xt value here, because when x is equal to the xt value here, this expression in the bracket becomes 0, and so f of x becomes negative 13 over 12, and that is when f of x is negative 13 over 12, when x is equal to 5 divided by 6, such that this expression becomes 0. And so the minimum value of f of x is the yt value that we calculated. That's a y value at the turning point, the minimum turning point on the graph of this quadratic function. And so the minimum value of f of x is yt, which is negative 13 over 12. And this minimum value of f of x occurs when x is equal to the x value at the turning point. That's the xt value here, 5 divided by 6. And so that is the answer for this part of question 9b. The minimum value of f of x is yt, which is negative 13 over 12, and that minimum value occurs when x is equal to xt, the x value at the turning point, which is 5 divided by 6. And that's the answer for part 2. Let's move down now to part 3. Now part 3 wants us to solve this quadratic equation, giving our answer correct to 2 decimal places. Now this quadratic expression is the same quadratic expression from the function, and so we could use a vertex form for this expression to solve this equation, right? And seeing that we are told to give our answer correct to 2 decimal places, that's an indication that this quadratic equation cannot be solved by the method of factorization, meaning this quadratic expression cannot be factorized in the normal way. And so the popular method to solving equations, quadratic equations of this form, is to use the quadratic formula, which for any quadratic equation in the form ax squared plus bx plus c equals 0, the quadratic formula produces the result where x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And as we have for this quadratic equation, the a is 3, the b is the same negative 5, and the c is 1. And all we have to do is substitute these values a, b, and c in this quadratic formula to get the values of x, which would represent the solution for this quadratic equation. And so we can substitute those values, and it's minus, that's this minus here, b is negative 5, so it's minus negative 5 plus or minus here square root of b squared. Again, b is -5, so it's -5 squared minus, that's this minus here, 4ac, that's 4 times a times c, so it's 4 times 3, a is 3, and c is 1. And now we are dividing the entire numerator by 2a, so it's dividing by 2 times a is 3. And when we simplify this expression, we end up with this. Minus -5 is 5, plus or minus the square root of, this works out to be 25. -5 squared is 25, minus 4 times 3 times 1 is 12. So we have 25 minus 12 here, which works out to be 13. And on the denominator is 2 multiplied by 3, which is 6. So this expression reduces to this. And so one x value will be obtained using the plus, and the other x value will be obtained using the minus. And this is it. X equals 5 plus square root of 13 divided by 6, or x equals 5 minus square root of 13 divided by 6. One value of x for the plus and one value of x with the minus. These are the two x values. And if you use a calculator to do this calculation, we end up with x equals 1.43 from here, or x equals 0.23 from here. And these are the two roots of this quadratic equation. And that's the answer for part 3 of question 9b. And so we have completed question 9, and we'll do question 10 in the next video. Alright, see you then.